Hey everyone, so today I'm going to just try to do some Linux kernel development basics, like downloading a kernel and building it from source, and just seeing if we can get that far and just build a little basic kernel and go through those basic workflows. Cool, so I'm going to start out. We're going to need a kernel, and so I think a good place to get one is Greg Crow Hartman's stable Linux tree. So I'm just going to code and git clone dep1. Man, that's annoying. Oh, oops. Okay. So I don't want to download the whole history because that's not what we're going to need today. I literally just want the latest, I guess, long-term support release maybe. And actually, this is probably not downloading that. We might need to fetch it. But this is a pretty decent way to get a kernel. This kernel build deps. While we're at it, we're going to need to it's in the way. Wow, that's what the hell. Okay. Yeah, move this up here. You need to install a bunch of stuff. You need a bunch of stuff. I'm just going to copy and paste this list. LVM. Jesus. It would be nice to know the exact list of dependencies needed. Another way you can do this is you can go to my blog, and I have a blog post on this topic. And at one point, I figured out some of this stuff. So kernel package. I don't know. Man, sorry about that. Okay, so make GCC. These are mostly some of the basics. So I have my Linux, and what I want to do is I want to get checkout to not really master, but 6.1. Linux.6.1.y is the yeah. So why did I choose that? Kernel.org. Linux 6.1 is the latest long-term support release, so it's pretty new. And that's as good, I guess, as a commit as any. If we wanted to be even more cutting edge, we could do a stable one, but it doesn't really matter. So Linux 6.1.y. Origin. Git fetch. That is, what is going on here? Go check out. Okay, well, this is kind of annoying. Maybe it doesn't even matter. I think I'm just so if I just literally clone it, then it just checks out to the current main line, and that should totally build also. So yeah, let's just build a mainline kernel. It doesn't really matter. I don't immediately know why this checkout doesn't work. It's probably something very simple that I just don't remember with Git right now. But doesn't matter. So we have a kernel source, and the first thing we need to do is make a kernel configuration. And let's see. So I think make def config usually does this. And there it is. We have .config now. And has all sorts of stuff in it. Just curious, how many lines is it? It's long. So yeah, we'll see if that works. And if we wanted to actually customize this, make menu config is the way you do this, and it puts you into this kind of GUI program, and you can just kind of go around, turn things on, turn things off. Yeah, pick what you want to be built in, what you don't need, stuff like this. For example, we could go to device drivers. Let's say we didn't need PCI support, or let's say we didn't need SATA or something like that. We just flip that, and then you hit save, and it writes a configuration. Then you can just get out of that. So next, so I'm just going to go back to here. So in this case, I'm running on a M1 Mac, so it's actually a 64-bit. Oh, I wonder what this is. It's a 64-bit ARM virtual machine in Docker. But I think this might actually be it. So if we just do, I think, make J5 or 6 or 7 or something like that, and proc +1 is maybe the, it starts compiling, a ton of device trees for some reason. I guess that's the default config. And it's just going. And we're off to the races. It's that's pretty much it. It's not too hard, actually. Just download those dependencies, generate your config, and then you just get building. And in this case, I think we're actually going to be building an ARM64 kernel, because this is just an ARM64 host. And it's just going to do that. It's building some modules, I think. I think that's what the M means. So that's pretty interesting. But actually, I'm just going to stop there because that's not totally what I want. So that just demonstrated a most minimal build where the object files go into the source tree. But if we want to do an out of tree build, that is a little bit different, but it's a little bit nicer because then the object files and all the build artifacts are not in the source tree. And so if you wanted to, you can just blow away and delete your build directory and rebuild. And that's much easier to do if it's a separate directory. And the way we do this is we start using this O equals thing. So rather than doing make def config, which puts the config locally, we generate the config in this remote place. And as you can see, I already have it, but what I'll just do is I'll just linux-build. Now we make the default config there. And now we do our build, and it gets going and starts building our kernel, which is pretty cool. I wonder how long it will take. A kernel build doesn't take up too much memory, actually, about 1 gigabyte of memory, mostly CPUs. While it's going, I'm out of curiosity, I'm just curious, how would you generate a most minimal kernel configuration? Tiny config. Is tiny config an option? I think it is. For fun, let's just do that. Also, because it'll be faster, let's just try that. Now that we have our whole setup, let's try that. Configure the tiniest possible kernel. Oh, and it's already done. That's pretty cool. So now let's go to our build, and it's here. We have a file, VM Linux, which is a kernel. That's the actual kernel. So now we can take this one step even forward, and we can make Linux install. And so now we can do actually this is I don't totally know what to do. Is there a make file in here? So now inside, I think the build directory, we can do make yeah, I think it's install path Linux install. So now we're in the builder and install. And that actually installed a kernel into this install. We can also do modules install, I believe. So actually, in this case, our tiny config doesn't even have kernel modules available. And so that's really it. That's interesting. If we had some modules, it would then create this kind of lib modules structure, where then it would put in a bunch of modules. But that is kind of the basics. So we've taken a plain Linux source tree, which is actually just Linus's mainline tree at some arbitrary point in time, because for some reason it could not check out to the latest long-term support release. And then all we did was just install a few dependencies on Ubuntu and build it. One last thing we can try to do that might be kind of fun is actually install a cross compiler and do a cross build. For example, to 32-bit ARM. So in this case, I can, for example, I can download a cross compiler to 32-bit ARM, and we can try building a 32-bit ARM. And let's just try doing that. So we're going to do arch arm to def tiny config in this case. Nice. So now let's try to do the same. I think this might not work. Okay, that doesn't work because we didn't specify our cross compiler. This documentation file. Right. And the way it kind of works is you do what is it? Arm. Yeah, so you specify basically this kind of prefix, I believe. And let's try building that. That looks a lot better, making its way through the build. So, and I already finished. So in our previous one, elf 64-bit executable ARM AR64. And if we go to Linux, build ARM32, we can see that it's elf 32-bit ARM. And so in this case, we were actually able to download a cross compiler, a pre-built one just from the apt repositories, and pass it into the kernel's build system and use this cross compiler to build a kernel. And we can, for completeness, do Linux install ARM32, and then we can do make install path install 32. Oh, and I think this is interesting. So do we also need this thing? Oh, we need arch arm, I think. Okay, that'll do it. Nice. And so let's take a look. I guess they look pretty. Oops, what did I do? Yeah, so they look pretty similar. But there we go. We have file Linux install, just out of curiosity, ARM32. Aha. So note that these files are kind of generated at the install step. In the plain build directory, we have just a VM Linux, and that's it. And then it's the install step that actually turns it into this VM Linux with a Z, which is a compressed kernel image. And interestingly, file does not say anything about the 32-bit one. But yeah, so that's pretty much it. Just wanted to share a bit about some kernel basics.